Okay, it's all you guys. Have fun. I guess it's not fun, but it's gonna be random derivative problems. Additive if you are yeah, not necessarily fun, but a few interesting ones at the end. Bring this into your brain before you go on vacation. Or 4 minute Robert next week. I was trying to figure out what he was doing there. That's what always try something. Yeah. Your life complicated. Remember the square roots and just we changed index moments. And That's what I was saying. The hardest part with like what you're doing here is going to be like what rules should you use, when should you use it, why should you use it, those type of things. Because when we were going through it, everything was broken down very simply. So all right, try this one. The pi and the x is inside the sign. So there's not really, you don't necessarily need the parentheses, but that should be there. That's why, so unless there's, if you don't see parentheses, you can assume everything after the sign is part of that sign until you get to like a plus or a minus or something like that. Well, okay. You kind of need it, but not. It's just a philosophy. This one. Huh? What? This? I don't know. It's at, well, kind of. It's the reader I got from my Portuguese friend. Like this with big shirts. What do I do? Well, the X. But that's the other one. You can't put it. It stays. Yeah. You can, the only thing you can do is plot the X. Oh, okay. I never know what. Remember the chain rules when you have a function outside of a function. So you do actually kind of do the chain rule for this one. But it's kind of one of those, it's the implied one just because of the pi in there. But the main thing you have to do with this one is the product rule. So we have f of x is x squared, so f prime of x is 2x. G of x is sine pi x. So g prime x is pi cosine pi x. So the pi comes out, that's the chain rule. Because in essence, you're doing, if u is pi x, u prime is just pi. So anytime you have just a constant like that inside of it with next to the x, the constant just basically goes out in front of it. And remember, pi is a constant. It's not a variable, so you don't have to do any calculations or anything else with it. So we do the product rule, which is f prime g plus fg prime. So I have 2x times sine pi x plus x squared times pi cosine pi x. So and you can leave it like that, or you can plot an x. There's not much else you're going to be able to do with it. What's the derivative of secant? Because I don't know it off the top of my head. Uh, this one's changed. Probably that secant is decided on. Oh, that's the ln is down at function of the sum. Frequently change. So don't, that's. Because that's not element, that's they don't do. Yep. They do something. So this one we have to do chain because that's inside of the ln of x or the ln. So u is secant of x. U prime is secant x tangent x. So then y of u is ln of u. Y prime of u is 1 over u. So then y prime is 1 over secant of x times secant x tangent x, which means y prime is just tangent. Because the secants can cancel out. All right, try this one. X plus y squared. That's the same thing. Square plus y squared. Yeah, do that. equal to what? The negative. Yeah, this is what you actually. You can, yeah, because of the we call the negative exponents. Yeah, the negative exponents. Yeah. Oh, I think you made the negative 2 is not the square root. Oh, the not fixed. The x one was negative.
It was negative 1.
Right, but when you do the derivative, it becomes. It's back one. Hold on. Oh, okay, that's fine. Yeah, that's.
Yeah.
Oh, I was looking here. Is that your final answer? No, that's that was my question. What happened to the negative 2 when you were here?
Oh.
That was
okay.
the, yeah. That's what I was saying. Like, wait a second. That's the thing. Where did they hear that?
Was it final?
Huh? Yeah, but we're gonna get rid of that in a second. Because it still is a negative exponent, right? Kind of, so I'm gonna show you because I don't think a lot of you guys will have to. It's like you want to get rid of all the negative exponents. Things about the file. It's like it's a matter of fractions and fractions. Yeah. Most of you got the actual chain rule correct. That's so u is 1 minus x to the negative 1. So u prime is x to the negative 2. And then y of u is u to the negative 1. So y prime of u is negative 1 u to the negative 2. So I have y prime is x to the negative second times negative 1. Actually, I'll just put the negative 1 out front. 1 minus x to the negative first to the negative second power. Okay, so that's the chain rule. But now we have a whole crap ton of negative exponents that I have to deal with because you really don't want negative exponents in your final problem. So this becomes 1 over x squared. We'll leave the negative sign on that one. And this becomes 1 over 1 minus x to the negative 1 squared. So now let's work with just this. We'll clean the bottom up. So that becomes 1 minus 1 over x, which becomes x minus 1 over x. Which becomes x minus 1 squared over x squared. So we have 1 over x squared times 1 over x minus 1 squared over x squared. And that's my final answer. It's messy. Yeah. So it really depends. Like it goes back to the thing. It's like negative exponents are messy to begin with. So probably if you left it with the negative exponents, I probably would have taken off a point just because you have negative exponents left in there. And this one kind of breaks down to something actually kind of nice at the end, but there is a bunch of steps to get there. So the thing about it is, if you tried to go through and do it, you wouldn't have lost any more points. So like if you were here, you had to this or you had to this, because I wanted at least those negative exponents together. But if you forgot that negative one inside there, I would have probably just taken off a point because of that negative side. But like if you had tried this and got this wrong, I wouldn't have said, "Oh, you got lost more points," because the goal when I'm trying to test this is I want to make sure you understand the chain rule and those type of things. So all right, try this one. This one's got so many little things in it that. About 2 different ways to do the chart already on the ground. I should start the problem if I'm going to do it the way you guys are doing it. Okay, so I got, oh, there's no way I'm fitting that all in there. So we're going to do it this way. I should have cleaned that one up a little more. So we've got 8x, x squared plus 1 to the third times 2x plus 1 to the third, 3x minus 1 to the fifth. Minus. x squared plus 1/4. Oh, okay, let's do it this way. All over 2x plus 1 to the 6th, 3x minus 1 to the 10th. Find an easier way to do it now? That's the hard way. Which you should have done. Take the ln of the whole thing. So you have ln of y equals ln of that whole thing. Because then we can split up our ln's. Minus So now we can do our derivative of each side. So this is 1 over y prime equals 4 times 2x over x squared plus 1 minus 3 times 2 over 2x plus 1 minus 5 times 3 over 3x minus 1. And then I can bring the y over. So 8x over x squared plus 1 minus 6 over 2x plus 1 minus 15 over 3x minus 1. The only thing which we have to do is we have to replace the y. And this one is fine. You wouldn't have to break this one down any further. You could get it to look like the other one, but yeah. So it was still a bunch of steps, but the steps here, I think, are a lot less fraught with mistakes that could possibly be made than I can almost guarantee you made some kind of mistake with all these steps over here with the exponents and everything else. Like, there's a lot of little places that you could easily make mistakes in here. And I did a lot of implied chain rules. I didn't actually write out all the chain rules for each one of these because every one of these had a chain rule done to them. But the same thing over here. Notice how when I did it, the ln of x or ln of u is just 1 over whatever it is. So I just put that underneath the bottom, and then that piece right there, that's the chain rule part. The chain rule of x squared plus 1 is 2x. The chain rule of 2x plus 1 is 2. 3x minus 1 is 3. So that's that chain rule piece. So the more you do them, the better you're going to get at doing that type of stuff and not having to write out every little step of those things. But I will tell you, that just takes practice. It just takes doing a bunch of the problems over and over again. And the same thing is going to be true at the end of the class and the beginning of Calc 2 when you're looking at U substitution, which is the integration side of it. It's one of those things that you're going to do so often with almost every problem you're going to be doing that you want to be able to eliminate having to write out those steps. So it's just a practice thing. Okay. The key with this one, though, is I wanted you to recognize that using LNs can save you the hassle of doing that whole quotient rule and everything else, which would save you time. All right, try this one. That's why you can match like a cloud on that. That's correct. Actually. If it was a little number up here, yeah, so that's fine. No, that's actually fine. You can factor something out of it. Hello. You can factor something out of it. You should have there.
Can't fix that. Or there's no negative. Is that correct on the test or is it?
Yes, no, that would be fine.
Okay.
But, like I'm saying, backdrop checks. Okay? And you're gonna know something happened real quick. Oh, you can't cancel the secants like you did it. Oh, yeah. Yeah, this is. Oh, yes. Okay. What was secant tangent, right? And what was tangent? Secant squared, correct? Zero anyway. The actual way that it ends up working out when you do the derivative, the absolute value sign doesn't impact the answer at all, except at 0. So because the actual either sides are going to be identical, so it's still just 1 over x. Yeah.
Why is there a 5?
So whenever I do either of those derivatives there, that's a U substitution. So it's the derivative of 5x. So you have to pull out that 5. So that's where that 5 came from. And the same thing on this side, you still have to pull out. That's why there's a 5 there and a 5 there. Yeah, that's the chain rule. So there's the chain rule that we did here. Like that's a full size chain rule. You have to do it out because there's actual derivatives and stuff like that. But we do that when we do these, it's called like an implied chain rule. It's like you're doing it, but because all it is pulling out a constant or doing something very simple in there, you don't really want to have to write all those extra steps down. So like I could have easily changed that and you could have wrote that out like this. Oh, close. That was what I want. So I could have said, okay, so secant 5x, so u is 5x, so u prime is 5. So that becomes, and then secant u is secant u tangent u. So then secant 5x goes to 5 secant 5x tangent 5x. So you can sit there and write it all out. But what you want to start doing is being able to identify those little things that you don't want to have to sit there and write out. Yeah. Yeah. No, that's fine. But that's some of the things that you have to look at and recognize. And that was the same thing I kind of did up here when I did these. It's like, okay, there is a chain rule in there, but it's simple enough that I don't want to have to sit there and write out all the extra steps. So you just do it. And you just have to remember you're multiplying that by. That's the same thing I did here, I did with the 5s on that one. All right, try this one. Oh, wait. never mind. Okay. Oh, that. That's the front. And then build the button. That's fine. Yeah. Okay, so that includes wide front, wide shoulder. Should have any more questions. This side, the left side, it's the position. You do on the right side. Trying to figure what you did. Okay. Alright, so we started here. So. I don't know if I'm blocked. You lost the Eagles.
That was just.
I'm trying to follow the process.
Probably wrong.
And it might be, but I'm trying to follow the process. Okay, so we got,
So,
okay, so we took that, we divided everything by y. Okay, so then you have that divided by y equals x1. Then you divide it by x.
which was here, but this was next anyway, it's just this part. So.
Okay, that's fine. Okay, got it. Okay, so you're here. Okay. Um. It might work. You haven't done anything wrong, but now you have a motion, what do you have to do it? You did your part. Okay. Yeah, this is a derivative. Yeah, your product of the one. That is not that.
Those eggs.
Right, but no, we just have one. If we. So the derivative of that is one. How do I square? So I would do this one square. Oh, wait.
Yeah.
Okay. But then the other side would have been this derivative of x times y. Oh, wait, never mind. Okay, never mind. I know, it's just, you're, the honors all this stuff, and that's, yeah, totally, yeah. Okay, that's fine. Let's see if I can. Do the, could you just derivative of y into y, it's y prime. Okay, so lots of interesting ways to try this. Now let's go through. So when we're looking at this, whenever you have y's and x's all mixed up and you can't solve for y, you want to do implicit. I figured out the mistake on yours. When you divide by y, you've eliminated information. So don't do that. So that would end up screwing things up. It'd be like saying, like, if you have x's on both sides and you divide by x's and it's like then 1 equals like 2 and things like that. Those strange things come up when you try to eliminate things. Yeah. I was like, I knew there was something there. Like, you could do that. All right. So we're going to do implicit differentiation. This side is just addition. So we can just do the derivative of each piece. So y becomes y prime. ln of y becomes 1 over y times y prime. Because whenever you do the derivative of y, it becomes y prime. So that y becomes a 1 times y prime. Actually, I'll put the 1 there since I did the other stuff anyway. So this becomes y prime times 1 plus 1 over y on that side. Does that make sense? On the left side? Okay. I just pulled out the y prime. So it's the derivative of this, which is 1 times 1 y prime. And then the derivative of ln of y is 1 over y times y prime. All right, now this side, we have to do the product rule. So x goes to 1, and y squared goes to 2y y prime. So I have equals 1 times y squared plus x times 2y y prime. Okay, and actually me splitting this out like this is actually going to make my life more difficult, so I'm going to change that again. So we're going to go back to the y prime plus y prime over y. All right, so we have, and this becomes y prime plus y prime over y equals y squared plus 2xy y prime. Okay. So now I want to move all of my y primes to one side and leave everything else on the other side. So I'm going to move this over here. So I have y prime plus y prime over y minus 2xy y prime equals y squared. Now pull out the y prime. So y prime equals y squared over 1 plus 1 over y minus 2xy. And if for some strange reason you really hate the double fraction there, you can multiply everything by y. You can multiply the top and the bottom by y, and we'll get rid of that fraction. So it becomes y to the third over y plus 1 minus 2x y squared. No more fraction. All right, find me my tangent line. might skip one after this one. Knowing at least that is going to be extremely helpful going through and doing problems. You don't necessarily need to know the whole unit circle because technically, if you know that part, you can figure out the rest of it. But knowing that part is going to be very helpful. That's where. You actually sign that. And then if we want to, if we want. So we do is just sign that. So we go further, yeah. Okay. That's fine. Plug your numbers into that. Find your slope, to find your actual number, value of slope. Don't take that whole answer, look at it, what's wide. And we now have, we have pi over 6. So plug pi over 6 into this, you get an answer.
Oh.
Looks good. I don't know the exact answer, but your possible. I just do the channel. So you rewrite this. Have your or where you do something. You was not going to so that was the side. And then, yeah. And then 80. That's critical one. And now you have to do the other stuff. It's still. Okay, I'll do it in a movie. We're gonna do your, wait, when you start. Oh, you were just fine. I need to sit that. Okay, so, and I know why. So first step, that is the same thing as saying that, which is what you tried to do with 5x. Okay, that and that are the same. So sine x is inside, so that's my u. So my u is not sine squared x, it's sine x. So du is, or u prime is what? What's the derivative of sine x? Cosine x. And then I have y is 4u squared. So y prime is 8u u prime. Right? That's the chain rule. So y prime ends up being 8 times sine of x times cosine of x. So that's the chain rule. We're not done with the problem. That's the chain rule part. Now I have to plug in pi over 6. So y prime of pi over 6 is 8. Pi over 6 for sine is 1/2. And for cosine is square root of 3 over 2. So it's going to be 2 square root of 3. And that's my y prime. That's what goes in here. So then I have y minus 1 equals 2 square root of 3 times x minus pi over 6. And that's your y.
There's not gonna be a question like that on the exam, right? It's all just derivative.
Well, like this? Yeah, there could be this. Yeah, there could be this on there. Because you're still finding the derivative, you're just using the derivative to do something else afterwards. There won't be one like this on the test. But I want you to try it. I want to see, so this is one of those brain problems. It's literally supposed to make you confused and try to figure out where you're going. I want to see where you would start. So try something. Okay. We've only done so many things. You know, you're probably going to have to find a derivative somewhere. Start there. And you're only using the X. A's, B's, and C's and stuff like that are constants. So treat them like they're numbers. You could. I don't think it's gonna help you. So after we come to the derivative, try derivative. You only got one equation. Find the derivative of it. That would be correct. So that's going to help when we know A and B. We have to find those before we can self-realize. Find the derivative of the original. Find the derivative of the original. Yeah, find the derivative of the y equals. Start there. That's correct. That's fine. Also plugged in with the slopes. Y prime. And we're gonna have two of them. Okay. Step one. Calculus for doing derivatives. Find the derivative. This one should be really simple to do. This was a simple derivative. That's the derivative. What now? They give us information that talks about a derivative. Slopes. Slopes are derivative, right? That's what a derivative is giving me. It's a slope at a point. So it says at x equals 1, the slope is 6. So let's plug that in. So 6 equals 2 times 1, a plus b. That's because derivative is slope, so that's 6. And it's at negative 1, not positive 1. And then the other one is negative 2 equals 2 times 5, a plus b. You now have what? You have a system of equations. Find me a and b. There's a reason I'm having you do this problem, because when we go into chapter 4, we're working on graphs. So, and a lot of them are going to be polynomials and things like that, looking at how we find pieces of information. So it's a nice lead-in problem to that. There's your system. Thank you. Maybe. It probably won't be on the exam at all. So I now have A and I now have B. I just need to find C. Yep. Plug it right back, plug in the 1 and 4. So we have 4 equals negative 2/3 times 1 squared plus 14/3 times 1 plus c. What? What one? 4 minus 4 is 0. Yeah. Because we're adding, so we get rid of it by subtracting. Now the question is how many of you told your bosses are off next week? Nope. Still here. All right. Have a wonderful week. I will post the review test at some point next week, probably earlier, probably like either Saturday, it's probably Sunday actually. So I'm not doing anything on Sunday. So if you want to get a head start and work on that, and you can also work on the homework in WebAssign. Tuesday when we come back, we'll do the review for the test, and Thursday's the test. It is the 27th. Is the test. Yeah, it's good practice. Me too.
I'll send you the email.
Yes. Yeah.